Okay, what we're going to do today is I'm going to give you some materials, and with these materials that I provide for you, it is going to be your job to design a working running model that demonstrates both osmosis and the process of diffusion. I'm going to provide for you the materials that you will get to use to make this model, but I'm not going to tell you what it is you need to do with these materials to build the model. Now, when thinking about what you're going to do, I want you to understand that you have to show me, both in a qualitative and a quantitative way, how you are going to show that osmosis and diffusion is occurring. The first thing I'm going to give you to use is a piece of what feels like plastic, as you'll see, and it's called dialysis tubing. And what this dialysis tubing does is, well, its real world purpose is to actually, it was for the process of dialysis, which some of you may know somebody whose kidneys no longer function. And so what needs to happen is their blood is fed through this tubing, and the tubing, just like the cell membrane, is selectively permeable. And what we mean by that is that the holes at a microscopic level, and even a sandwich bag has these microscopic holes. The holes are so small that when this is bathed in a solution of water, we'll pretend like this is water surrounding it, the red blood cells are too big to get out of these holes. Now, red blood cells, they're going to want it, inside of the tubing is where the blood is. And so there's obviously a higher concentration of red blood cells inside of the tubing compared to outside, because this is water out here. But I'll write water right here. So these red blood cells, as much as they want to go from an area of high concentration of blood cells, which is on the inside, to low concentration, which is on the outside, they can't get out because these holes aren't big enough to let them out. However, I'll put another red blood cell there. The toxins that are in your blood that your kidneys would normally be filtering out, there are none of these toxins in the water surrounding the tubing. But these toxins and waste products are so small that they can, by diffusion, get out of these tiny holes and make their way into this water. So this is called dialysis tubing. And again, it is a semi-permeable membrane because it discriminates against particles based on the size of those particles. So I'm going to give you a piece that's about 6 inches long, as you can see that I'm holding here. The second thing I'm going to give you is I'm going to give you some iodine. Now, you remember that iodine, we've used this in other labs before. We use it to stain things, to view under the microscope, and we also used it as an as a reagent to react with starch. And remember, it turns purple, or darkest purple-black, when it's in contact with starch. So I'm going to give you as much of this iodine as you want. I'm going to give you a solution of starch. This is the powder form of starch right here, and what I'm going to do is I'm going to mix it up in water. And so we're going to have a somewhat liquidy solution, and it'll be a pretty strong solution, and you'll have as much of this starch liquid as you possibly want. And I'm also going to mix up a solution of a monosaccharide called dextrose, and I'm going to mix this up for you, and it'll behave just like glucose would, except this is another monosaccharide. And so this will be in a liquid form as well. I'm going to allow you to have what is called a glucose test strip. And the glucose test strip looks like this right here. And you'll notice at the end of it's got a little bit of a little plate on it that's got a chemical on it. When it is in the presence of certain concentrations of glucose, you'll see that there is a calibration here, and you can run through and you can look to see by matching up what you've dipped this in, you can go through and you can see how strong of a solution you have of glucose. So I'm also going to give you one of these. I'm going to give you a beaker and water, and of course everybody knows what a beaker looks like with water in it. And so these are the materials you're going to have. And what I'd like you to do, and remember, you need to do both a quantitative measurement, and you also need to do a qualitative way. In this model, you are doing both of these measurements, both of these observations, and you have to show me in your model that both osmosis and diffusion is occurring. I'm also going to provide for you a digital scale, and I'm not going to put that under the camera here, but you know what a digital scale looks like. So I'll write these items down here for you. I'm going to give you iodine. I'm going to give you dialysis tubing. I'm going to give you a starch solution. I'm going to give you a glucose solution. In this case, I told you it was going to be dextrose. And I'm also going to give you a beaker, and I'm going to give you water, and I'm also going to give you test strip. So it is your job to build this model, and then again, you have to show me, and I'm also going to give you the scale, forgot about that. In this model, you have to show me both in a qualitative way and a quantitative way how osmosis and diffusion is occurring.